In this problem, we're asked to find the greatest common factor between the three different terms. If we look at the numerical parts, 42 happens to be made up of 21 times 2. This is 21 times 1. And this is 21 times 4. So the largest numerical factor is 21. Let's look at the x part of each term. There's 1x here, there's 3x's there, and 4x's there. What's the most that's in all three places? That would be the letter x. Check on the y's. 4 values of y, 1 value of y, 4 values of y. The most that's in all three places is the letter y. So 21xy is the most common factor to all three terms. Here we have a trinomial where the leading coefficient is -1. Notice there's a negative in all three terms, so let's extract the largest numerical common factor, which is -1, and we'd be left with x squared plus 16x plus 15. We now have a trinomial that may further factor. Its leading coefficient is 1, so it's the easy type. If it factors into two binomials. Factors of the first term x squared go into the first slots. Possibilities for the last term are 15 and 1 or 5 and 3. Examine the choices. Which choice would either add up or subtract to give the middle coefficient? Well, this one here, if we add up 15 and 1, we get 16, so I think that is the right choice. And now we need to choose the sign of the middle term. The inside product is 15x. The outside product is 1x. And we want a result that's plus 16x. To get a bigger number and positive, then both signs have to be positive. Place them in. Double check that the product of the last terms plus 15 times plus 1 is plus 15. Then this trinomial did factor, and it's factored completely. The next problem also is a trinomial where right now the lead coefficient is greater than 1, but there I see that there's always pull out a common factor first when possible. We can extract the 8 from all three terms. That leaves me with x squared plus 5x minus 6. It may factor further. Its leading coefficient is a 1. If it factors, it will be into two binomials. First terms would be x and x. Now factors of 6 are 6 and 1, 3 and 2. Which pair might give me a product or give me a sum or a difference that's 5? Well, 3 and 2 adds to 5, and 6 take away 1 is 5. Let's try 3 and 2. Inside product is 3x. Outside product is 2x. Make them both positive to get 5x. But unfortunately, the product of the last terms is plus 6, and we want -6. So that was a bad choice. Let's try it again. But instead of using 3 and 2, let's use 6 and 1. Inside product is 6x. Outside product is 1x. The result wants to be a plus 5x. We need to have a smaller number, so the larger number takes the positive, the smaller number takes the negative. Pushing the signs in and checking the product of the last terms, plus 6 times -1 is -6. So the correctly factored form is my second choice. We would like to factor this trinomial. Again, there is a common factor. 2 is the most that's common to all three terms. And looking at the t's, the most that is common is t to the 5th. So we're going to pull out 2t to the 5th from each of the three terms. We're left with t squared minus 3t minus 4. This trinomial may further factor. It's a simple trinomial. Leading coefficient is 1. Factors of 4 are 4 and 1 or 2 and 2. Which combination would either add or subtract to give me a 3? That would be this one here. So we're going to have t and 4, t and 1. Inside product is 4t. Outside product is 1t. And we want the result to be a negative 3t. To get a negative sign, the bigger number takes a negative, smaller number takes the positive. That does give me negative 3t. Pushing the signs in and checking the product of the last terms, minus 4 times plus 1 is minus 4. So we have completely factored the problem. It says factor by grouping, but if it didn't tell me that, if it just said factoring, I see 4 terms, and I'm looking to see, is there something common to all 4 terms? And I don't see anything common to all 4 terms. So when we have 4 or more terms, we think of grouping. Let's separate the 4 terms into 2 groups. Separate, that means push the terms apart. I'm going to put 40xy minus 56yz in the first group. And over here, the second group is plus 45xz minus 63z squared. So I separated 2 groups. Let's put parentheses around each group, but separate them always by a plus. Separate the groups and put a plus in between. Now from the first pair, is there something common? I think 8y is common. So I pull out 8y, I'm going to get 5x minus 8 and 56 is 7. Pull out a y, I'm left with z. From the second group, let's see if there's something common. I think I see a 9. And I see a z. So pulling out the common factor of 9z from the first term, I have 5x. From the second term, I have negative 7z. So we separated the 4 terms into 2 groups of 2. Now that we factor those groups, we see a group that is common to each of the 2 terms. This group and this group is common to both terms. The group is 5x minus 7z. But we need to put a parentheses. Without the parentheses, we'll get in trouble. So that group is common. When we extract it from the first term, we're left with 8y. And from the second term, we're left with 9z. We have now changed the sum into a product, and that's what factoring is all about. It's awkward factoring a trinomial where the leading coefficient is negative. So it's my preference to extract a minus 1 from all 3 terms. Therefore, I'll be left with r squared plus 3r minus 10. So now we have a trinomial where the leading coefficient is positive 1, not negative 1, but positive 1. Let's see if we can further factor this problem. So r and r are factors of the first term. For 10, the factors are 10 times 1 and 5 times 2. Which pair would either add or subtract to give me the middle term of 3? It's 5 and 2. The inside product is 5r. The outside product is 2r. The result wants to be a plus 3r. To get a plus 3, we make the bigger number positive, the smaller number negative. Push the signs inside and double check to see that the product of the last terms is minus 10. And it is. That's the completely factored form of the trinomial.